lab, we revisit the lesson that we did in algebra and just make sure that we can check off all of the learning targets. So what we actually did in class was explore data and describe distributions. What you will be assessed on Friday specifically, you'll be assessed directly on this, is describing the shapes of distribution using terms like symmetric, skewed, uniform, bimodal, and bell shaped. Notice that we did not write formal definitions for any of them, but say you want to make flashcards because there is a lot of vocabulary in this unit. Just want to show you, I'm showed this to you before, but everything is always in Schoology. If we're referring to the lesson from algebra, then it's in the algebra Schoology. And you could always look at the teacher notes. I have lots of stuff unpublished that's already ready for you, but we're trying to look at just today's. All right, and today was August 6th. We did this lesson. Should you want to make note cards or something like that, there's usually a glossary at the end of each note thing I post. So here's our bell-shaped distribution definition and a picture to go with it. You could probably even find some stuff on Quizlet already made. If you just type in unit 1, illustrative mathematics is our curriculum, algebra 1, 2, they're probably already made. But just for your reference, if you want them to be written out, if you want to add these to your notes, you absolutely can so that you have them for the quiz on Friday. All right, but otherwise you practice how to identify these in the real world. So hopefully that is enough from what we did in the lesson today. One thing I know you guys might be having trouble with, because you didn't see it in the lesson directly, is the box plot. So in the lesson, we mostly looked at symmetric dot plots, histograms, and things like that. There is one more distribution that you'll come to learn on Thursday, and that's called the box plot. So it's those things that look like this. So this would be an example of a box plot that is symmetric. Because each part of it is about the same size. This would be a box plot that is skewed maybe to one side. All right, what you need to know about box plots, and I've not taught you about them yet, you'll learn them more on Thursday from watching that video, but that it spreads our data into 25% quartiles. So from here to here, from the edge of this whisker is what they're sometimes called, to the edge of this box is our first 25% of the data. From this box to the middle of the box is our second 25%. From here to this edge of the box is another 25%. And then so from here to this edge of the whisker is another 25%, to total up to 100% of your data being represented. So if you have one whisker that is longer than the other, that doesn't mean that there's more data here. This is still just 25% of your data. It's just more spread out. So if this is a box plot, its data might be the dot plot of it might look more like this, where you can better see that it is right skewed because it's more spread out on this 25% of it. Does that make a little more sense? Okay. You'll see those on your practice. So yeah, it splits our data into quarters. It still represents 25% of it, no matter how big or small it is. It just might be more spread out. So there's that. Also be able to make inferences about what data could represent, which we talked a lot about today. Things that make sense, things that don't make sense. So any questions on that? or anything from the lesson, it's like, or time to revisit it if there was something that makes sense to you. So you can show your mastery by getting 80% or higher on this practice. Some of you have already done that. Great, congratulations. We do have the rest of the week already posted. So consider maybe getting ahead. Like I said, that I'm having to sub the next 3 days. You have 3 homeworks to do. You have 3 note sheets to upload. Like if you want to get ahead now, if you're already finished with this, you can use this time to do it. And also for the rest of the week, you'll have time in here to finish what you don't finish in algebra. That doesn't mean you should just goof off in algebra, but there's no reason, especially you guys of all my students, should have anything missing from this week. You'll have more than enough time when you combine the 2 hours. Another thing though, I am having, because you have time in algebra, you have time in math lab. I do have to put just one more thing, like one more task for you to do, but it is also so helpful. And it's making a box plot foldable. So I had my TA make these, like fold them and staple them already. This will be your one thing I ask from you from math lab when I'm gone. Okay, so at the end of the week, Friday, you'll turn this in, there will be a folder. And you'll make sure you have your name on it, you'll turn it in and it'll be a project right, okay? And really, it's just examples of box plots. It'll probably make more sense once you do the Thursday lesson, but I imagine you'll have a lot of extra time. Because you'll have algebra and in here to do the same assignments, nothing else except for this, like nothing extra except for this. So any questions? Okay, so then I already reset one person that asked. They needed a second attempt, or a third attempt rather. So I already did that for that person. If you use up your 2 attempts and you're still not getting the 80% or higher, please ask and I will give it to you so long as I don't think you're just guessing. Any questions? Okay. In the last 20 minutes, I'll offer to do whatever you want to see on screen, but that doesn't mean you have to wait till then to ask. You can always ask as you go to be more efficient. So here's a box plot that would be considered symmetric, all roughly like the same proportion. Here's a box plot that would be considered skewed. Now, what box plots do is they separate the data into quarters. So like my first 25% of data would be like the edge of my whisker up into the box. That's my first 25%. My second 25% would be like the box edge to the middle of the box. Then again to the other side of the box. And then this edge of the box to this whisker. So box plots show you how spread out the data is. Like this one's pretty evenly spread out. When you consider like a skewed box plot like this one, we have 25% of our data spread out over a larger section here. So would you say that this is left skewed or right skewed? If it's more spread out on the left. Right, yeah. This would be an example of right skewed. So like a box plot that would probably match this box or dot plot that would match this box plot would probably look something like this. Where data is more to the right. So actually, I think you're correct, left skewed, my apologies. This would be a box plot where more of the data is to the right, the void is on the left, so yeah, it's more spread out on the left. So that would be a left skewed box plot, okay? Other thing about box plots that you'll come to learn, but you might see on your practice, so we might as well talk about it now. The median, like your middle number of your data set, is the middle of the box. This is where your median goes. Your minimum and maximum would be like the left side would be your minimum, your smallest number. Maximum would be the far most right side. This represents your quartiles, and I don't think you need to go in depth like what, like. Your quartiles are, but we have your lower quartile and your upper quartile. The median is your middle quartile, if you will. So I don't think you need to know what those are yet. You'll learn more about them Thursday. But just know that like this would be the middle of my lower half, the middle of my upper half, the middle of my entire data set. So in box plots, you can't see each individual data point. You just know like 25% is spread out this much, another 25% spread out that much, and things like that. Okay, but today the main goal is to be able to describe the shapes. So any questions on that part of it? Okay, I'll come back to this, but I just want to show you. In Schoology, you're doing that practice. Some of you may already be done with it. 80% or higher is the threshold. So I haven't put any grades for that part of it yet in MATLAB, but I will soon. And I'll try to keep up with it as we carry on in the week. You know, like even though I'm on vacation, I'll still mark missing just because I don't want people to just not do anything and get 3 missing when I come back. I'll mark them as the days go on. So then when I am finished, not when I'm finished, when I'm gone, whatever lesson you were supposed to do in algebra that day, you could use this hour to make sure that it is uploaded to Schoology, the note sheet, and that the assignment is done at 80% or higher. I can still reset your assignments. Just message me and I'll get to it when I can. But that's your obligation. Upload your notes, do your assignment. In MATLAB, you have extra time to make sure that gets done. The only thing I'm having you do extra while I'm gone, because that is a lot of time, 2 hours a day to get like 1 lesson done. The only thing extra I'm asking you to do is this box plot foldable. So it says right here, blank box plot foldables. I'll have another folder where you turn it in, but you'll just like, when you're finished with your assignment, you'll grab it, put your name on it, start working through it. It'll probably make more sense to do it Thursday because that's when you'll learn more about box plots, but you're welcome to work ahead in here too. So yeah, this will just count as a project grade. I'll have a different folder where you can turn it in and check your answers, but this is where you'll get like the blank ones. What else about that? So other than that, you're just doing your normal work in algebra in here, plus that foldable. So any questions right now? You're more than welcome to ask questions as you go. But I also typically will check in the last like 20 minutes or so and do whatever problems you want to see on the screen. Last hour, I had someone wait right until like literally the last minute to ask their question. So like I would have liked to have more time to explain it better. So like, please give us enough time to ask questions and get them answered. Any questions? So it is the unit 1 lesson 4 that we did today. So you're welcome to work ahead. If you need any materials, let me know. You need your 5-number summary. So the 5-number summary includes a minimum, a maximum, a median, and then your lower quartile and your upper quartile. Same values that it asks you to identify here on the side. Some of them use slightly different verbiage, but hopefully you get this. You definitely want to make sure, because since you have to find the median anyway, that your data set is in order. Okay, so from least to greatest, this one already is. So my least value is what? My greatest value is So those are other words for minimum and maximum. And then you would have to find the median before you find your lower and upper quartile. So median means the middle number of your data set. So you just kind of go left, right, assuming the data set's in order, which it is. So like left, right, until you get a middle number or middle two numbers. So if I have an even number of data points like I do here, I should expect there to be two numbers in the middle. And what happens when I have two numbers in the middle? You find the average of it. Good. So I'm gonna add up the 14 and 16 and then divide it by 2. That's what averaging is. You add up all the numbers, divide by however many you add. So 14 plus 16 is 30. 30 divided by 2 is 15. Feel free to use a calculator on that part. So my median is 15. And since it has to be like me averaging those two numbers, I will usually like draw a line. And that way I know that I never cross out the median when I'm finding my lower and upper quartile. So these words, lower and upper quartile, mean middle of your lower half and upper half. So here's my lower half of data. You never cross out your actual median. So since this is my median, I can cross out the 14. Never cross the median, kind of like when you draw it. And I have two numbers in the middle again. 10 plus 10 is 20, 20 divided by 2 is 10. Taking the average of the same numbers, it should be that number, but you can do the math to verify. And then the median of your upper quartile, of your upper half. Again, two numbers in the middle, 20 plus 24 is, and 44 divided by 2 is. So here's, oops, my upper quartile is 22. And since those are the numbers that I need to make my box plot, then I would create a number line. My number line's down here, but if I scroll, then my writing will get all messed up. So say like you had to make it yourself. You definitely need to contain all your data. So if my data starts at 5, maybe I'll start at 0. Since it goes all the way up to 38, I don't have a whole lot of room. Maybe I'll count something like this. And you put, did you have a 5-number summary? You need to put a dot where all of these numbers would be. Now, granted, your number line doesn't look like mine. Like yours has actual little values on there. Do it based on your values. I just don't want to scroll and mess up everything I wrote up here. But like my 5 would go here, 10 would go here, 15 there, 22 here, and 38 here. Your middle 3 dots, that makes up your box. So your quartiles, including the median. We call this, right over here, Q1, Q2, and Q3 for short. The second quartile, your median, and the whole thing. And then your box plot will connect, like, I don't know what you call it, to your minimum and maximum. So these are like your whiskers of your box plot. And yeah, so that's how you make it. Of course, there's not will look slightly different because everything counts by or something like that. But that's how you make it. And the question was about interquartile range. So interquartile range, you guys know how to find range like overall? Okay, so like normal range, not interquartile range, would be your maximum minus your minimum. So if you should think like subtraction, bigger minus your smaller. Interquartile range at that would be you taking your upper quartile minus your lower quartile. So like for this one, I would do 22 minus 10 for my interquartile rate, and then I get that my middle part of my data, my middle half, is spread out over 12 data points. Whereas my entire range, so 38 minus 5 is 33, is spread out over 33 data points. So does that make a little more sense? Any other questions right now? Maybe for practice, maybe for foldable. So when you just have one number in the middle, like what I would recommend is you just circle that number, and again, you never cross your median. So then when you're trying to find your lower and upper half, don't cross out the median, or left, right, left, right, left, right. Okay? All right. So if there's no other questions right now, then I'll leave you to it, but if you have any, just let me know.